एक बार पीपीटी देख लो मेरा, मतलब मैंने लोगो वगैरह का पूछा था ना, आपको दिख रहा है? किया मैंने स्क्रीन शेयर। ये क्या? अभी देखो, एक सेकंड, पीपीटी में बताता हूँ। हाँ ठीक है। हेलो, एक बार पूरा पीपीटी देख लेना। आई थिंक ये सब मैंने बताया था पहले, बराबर है ना? पीपीटी लाइक इज दैट फाइन? लाइव किया है क्या? As in? हाँ, अभी ठीक है। नहीं, स्क्रीन है पूरी। एक मिनट। अभी क्या है प्रेजेंट? अभी क्या लेआउट में साइड बार ही है ना? हाँ ओके, अभी मैं स्क्रीन शेयर कर रहा हूँ तो दिख रहा है प्रॉपर? आपका कुछ है स्टार्टिंग में प्रेजेंटेशन? एक मिनट।
Please start the stream, please.
Memories die out too hard. We were traveling the mountains just to find out out and seas. We set out by the fire, knowing we could aim higher, but we didn't know that yet. So if you want something to hold on to, gotta find it first. But here.
हेलो 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 एवरीवन, हेलो हेलो, आर वी ऑडिबल? हेलो, जस्ट पुट अ क्विक yes in the chat. Hi Palani, just put a yes in the chat if you can hear us. Hello. Yeah, is the audio?
Hello everyone. Am I audible? Hello.
Hello, hello. Yeah, yeah, yeah. Okay, okay. So let's begin. Good evening, everyone. I am Prasad Sawant from Let's Upgrade, and today we are going to learn how to create a COVID-19 app using AI and ML. So basically, the current situation, if we look at, coronavirus is like a global pandemic which is going on, and it has like covered almost around 4.64 million deaths cases till now, and it is ever growing. So like how can we, with the help of tech, monitor it, or how can we reduce, like if we are able to diagnose like the patients, how can we bring it in control? So today in this session we have with us who is going to take a small session up on how to create an app regarding this. So Ashish sir.
Hello. Yes, sir.
Yeah, so let's start with the session.
Okay. I think my screen is not getting shared.
No, it's visible. It's visible, sir.
Hello, everyone. It's Ashish here. Am I audible? Hello. Prasad, am I audible to you properly?
Yeah, just a minute. I'll check on the stream. I just Yeah, sir, you're audible. We can continue.
Okay. 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 Thanks for your response. Let's start with building your COVID-19 and looking at this session. Like, if you see the COVID-19 scenario, what exactly is happening in the environment right now? Like, if you see this situations, COVID scenarios, what are the things happening right now in the environment? First thing is lockdown. Second thing is so many restrictions. Third thing is no in-house meetings, no classroom interactions. Every single thing has been restricted. Okay, and if we see into this scenario, like what like when do you expect like uh, everything will get back to normal?
Hello, guys. Can we have a response? Sir has asked a question. Please put up your answers in the chat.
Vaccine has been found. Okay, so do anyone has an idea like is happening for the first time? This is a COVID-19 virus, coronavirus. Okay, what if there will be other virus, or we as a human have to be prepared for such situations? Okay, so as of now, would like occur, like everything happened, right? So everything and no one has an idea everything will be shut down. We will have so much restrictions. Talking about this corona, like I would like really working, like which includes our medical, which includes our police department, and like we as a developer, we are into tech, right? We people even to remove restrictions or some alternative for all this situation which is happening right now. Okay, so talking about problem statement, we are building a data science machine learning AI app for COVID-19. So, like, please respond what type of apps that you can build and use in such type of situations.
Somanshu Sharma is saying if we diagnose COVID-19 effectively, properly, may the situation get normalized.
Okay, but looking at the population we are having, like people might get missed. Like there are still chances.
Yeah, social
Like
gathering.
I'm asking about what type of apps can be built and used in such situations.
Guys, can you please put up the suggestions? Like looking at the current scenario, we already have some apps going on on the internet. what more can we do to help the cause? Like we have app for patient diagnosis, for age criteria detection, mass gathering, how to detect like if infected people around you. So what more can we do? Just put up in the chat.
So what type of apps like do you like? What I think is to avoid mass gathering, what we can do is we can make apps like queue management system where okay social positive okay which is already in the market, social distancing app which can be queue management for like people Google service and good services and grocery services. Okay, cool. So we can build a queue management system, we can build some thing, but where we can apply AI and ML in that. So let's turn to our topics. What are the topics for this today's session? First one is okay, app detect to where social media gathering is more. Okay, cool. So the main two topics for today's session is COVID-centric online education and second is mass detection. Okay, so like using AI and ML, what we can do is we can build an COVID-centric online education. Second one is mass detection. Mass detection basically is like to detect mask whether the person has is wearing a mask or not. That's it. But COVID-centric online education means what? Like right now I'm talking with you guys, right? So generally you do classroom trainings, classroom courses. It isn't it isn't exact same like your classroom trainings, right? In classroom you can see face of each other. In classroom you can exactly interact with each and every person. You can notice what each and every person is doing. And even if the teacher is talking or whatever, you can feel that environment, right? Which is not there right now, right? So such type of apps or such type of alternatives should be made in such situations, okay, and which can be even used later on, like to add more interactivity to online trainings or else online courses like the one which you are doing right now. Okay, so what we are going to build in this is COVID centric online education system. Second one is mass detection, and which we are going to build it live. Okay, I'll show you live how to build your own classifier, like how to build your own classifier for mass detection as well as detecting emotions or every single thing which you can do using your live camera. Okay, so why do online education is not exact same as classroom courses? I've already told you, like there is no live face to face interaction. Then second one is the trainer or the teacher don't exactly know what you are what you are up to. Like I don't know exactly how much you have perceived or how much you have received from my side. Okay, so this is lack in total lack in your online education, which we want to remove this gap. Okay, so for that we can what are the things you can do to remove this like face to face interaction, enhance this, what we can do. What if I told you like using your camera, whenever you're doing a Zoom meeting on YouTube live, you like everyone is not showing face, but what if you're doing a Zoom meeting, everyone's camera is on, right? So even if you don't wish to display your face, the camera can be used to detect how the user is interacting with the tutor or the trainer, like detecting emotions. If I'm sad, if the camera is noticing like how idle that person is, or whether I'm happy, not happy exactly, whether I'm smiling while listening to that class, so that means that I'm enjoying the class, right? And the same thing we are going to build it right now. And the second thing we are going to build is your face detection. Okay, so now I'll show you what exactly we are going to perform in this session. Uh, so I think for a minute I have to turn off this camera. Just give me a minute, or else age detection technologies. Okay, age detection is also the same. Like I'll show you how to detect and how to build the same app. So I'll use my internal camera. I'll explain the code files too, like how to build it in Python. Don't worry about it. Okay. So if I'm happy right now while looking at this video, I hope everyone is able to see this, right? Just let me know in the comments. And if I'm enjoying this session, if I'm happy while looking into this camera, it is showing enjoying. And if I'm just sitting idle, okay, I'm not into that frame. I have to be in that frame properly.
Sir, can you just zoom the code? Let,
I'll display the code. Like that's what we are going to build it.
okay.
I'm using webcam, so it is not like. Just give me a minute. I'll run it once again. Uh, like, can I use this? Where should I turn off my
Uh,
camera?
just a video. No, no, don't go there. There will be the option below. The behind this stop sharing button. Just close this. Just hide that.
Okay.
Stop sharing. Yeah.
Mhm. Okay. So, so I'll turn on my webcam actually. So as I'm sitting idle right now, like it is displaying sitting idle. Okay. But if I'm enjoying the session, okay, if I'm my face is happy, so it is displaying enjoying. Okay. If I'm sad or if I'm like laughing loudly, that means the user is interacting more with the video. Okay. And in the similar way, you can like actually increase the user's interactivity. Like you can do a proper analytics on this, like whether the user is actually enjoying the content or like user is sitting idle, and this will actually improve the analytics part. Like you can use it in your Zoom, you can use it in your YouTube video analytics is also better. Like you can also improve or enhance the YouTube video analytics. So I hope everyone has got the idea, and the same thing we can detect. I'll talk about the accuracy, don't worry. The same thing we can detect whether the person has like is wearing the mask or not, and that we are going to do it live. So are you guys interested? Like if you have got a clear idea what we are going to do, just please like yes in the comment section so I can get a clear idea about it.
Sasikaran will zoom the screen once we get to the coding part.
Yes, yes, sure. So if I'm sitting idle, it's just saying sitting idle, and that 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 is actually telling the tutor or someone like who is having the access to this and like we'll proceed now. I'm just closing this. We are going to start your actual image processing for this. Like we are going to detect live not face detection. We are going to do live mask detection. Okay. So let's get back to our PPT. What we are going to learn: convolutional neural networks, CNN based real time object detection. It's not just about detecting emotions, it's not just about detecting how happy you are, how sad you are. It is also not about mass detection. With this, you can detect any single object. You can detect as many objects you want, and you can do this project live on your own. Okay, so let's start with the presentation, like what we are going to exactly learn in this. So those who are starting into basics of data science, machine learning, and AI, I'll just like explain you what these things are. Data science is exact study of all the data in our environment. Okay, which includes structured data, which also include unstructured data. Structured means you can call it as a plain simple text. Unstructured means data is also available in the form of videos, in the form of images, and which is not properly analyzed by people. So what, as a data scientist, your role is to analyze every single data in the environment, and like for that you use various machine learning models, and also use artificial intelligence for that. Machine learning means the name itself says something like you are going to train your machine, okay, on the basis like so that your machine can learn and predict something on the basis of the data you have trained on. And artificial intelligence means like you are just making that machine art intelligent, okay. So if I talk to you about intelligence, what intelligence mean is uh, wait a minute. So if I'm talking about intelligence, is what intelligence means is making your machine smart. Intelligence exact meaning is like intelligence exact meaning is like ability to think, okay. And when you give this ability to your machine, that makes your machine artificially intelligent, okay. So now uh, after this, what we are exactly going to do, and like see, I'll tell you what are the types for this in machine learning models, what exactly the things are. Just give me a minute. Detection. So first thing I'll tell you machine learning, what are the models exactly in that, and you have to tell me what type of problem we are solving. The problem we are solving is of mask detection, whether the person has is wearing mask or not. So in machine learning, first one is regression. In regression, what we do is like we predict some value. See, all these technologies were developed like the way our parents has taught us, right? So that means like how they taught us, like they started telling us like this is the group of fruits and this is group of flowers, right? This is for classification. The same thing we are going to do in your machine learning example. Then for regression, after like we started predicting values, right? So like we are predicting values like weather prediction, then like exactly regression consists like which is dependent on some other thing. This is what regression exactly is. And clustering means clustering parts, and like clustering means grouping, okay. So we can group based on different characteristics, like there might be many fruits and flowers. So there might be mangoes, apples, then like different flowers, like whether the person is wearing mask or not, what type of example it is. Hello everyone, what type of example it is. We are going to detect whether the person is wearing mask or not. Please answer.
Hello, can you answer like is it classification or clustering? Hello.
Okay, classification, okay. So some people have told regression means it is dependent on some other thing, okay. But in classification, this like there is no dependency. These are two different things, like whether the person is wearing mask or whether the person is not wearing the mask, that's it. In the regression, it might be predicting something, someone's salary based on his years of experience, based on skill set that person is having. These are the regression examples, okay. But in classification, what you have is you're just classifying two different objects, and then the task which we are going to do is a classification one. Most of them have given the classification. That's good. Like they're getting the point what we are doing. Tech stack we are using is Keras, TensorFlow, and OpenCV. These are the libraries. I will explain what it is exactly. And tools which we are using Python programming language and Jupyter Notebook. Jupyter Notebook is a web-based interface to run your Python codes. Okay, so I'll explain all these libraries. So first, out of this top 10 data science libraries, you can use TensorFlow, and Keras is one of the most used libraries. Now, talking about TensorFlow, what we use TensorFlow for is it is an open source machine learning platform to build your machine learning apps. Okay. Then for Keras, we are going to use neural networks. I'll explain what it is. So now, talking about our topic, it is your mask detection, right? Okay. So now, this is an example of neurons. Okay, the way I told you, like it is not a very it is not exactly some type of innovation. We are always doing everything with like getting inspired from nature or like human beings. So the way everything like we learn, we humans learn, like it's like everything is happening in our neurons, right? These are the biological neurons, and this is a simple neuron. Okay, so I'll tell you, for object detection, you as a person, how do you identify whether you have seen any object? So, for example, I'm having an so let's take this cup. So, for example, how do you identify this is cup? Someone has taught you, right? Like the shape, something looks like this is a cup, right? So in the similar way, what we can do is, what we can do is we can train our machine to detect the same objects, like any kind of object. Okay, so what exactly plays role here is your neurons, and the same way we are creating neurons artificially in your system, and that is called as artificial neural network, which is used to detect objects. Okay, so we are going to train this artificial neural network, and it is exactly same as training your kid to detect some objects. So everyone, just tell me what are image consist of. What is an image? What does an image consist of? So image is consist of pixels. Okay, pixels. Okay, that's great. Image consists of pixels, and like if you see this, you are going to detect exactly the same way. See, in this smiley, you will get a value 1 exactly where your eyes and nose are. Okay, and this is how humans perceive. The left side, we are having images like how humans perceive, and at the right side, you're having images like how it is seen in machines. Okay, a colored image is having three channels. One is RGB, and like it is a combination of all these images, all these values, and how machines visualize it. It is on the right side. Okay, so now uh, what exactly it is black and white versus grayscale. For what we are converting it into black and white versus grayscale is like to reduce the process, to reduce the process. Okay, so now what we are having is uh, okay. I'll start explaining you the code and step by step. I'll also explain you the PPT. So first thing is to build such app. The first thing is to build such app. What we are going to do is you have to collect your data. The first thing you have to do is you have to collect the data. So for that, I'll explain this code line by line. You have to keep a working directory, and I think I'll just zoom it out. Let me know if the code is visible.
Yeah, sir. Now it's visible. Sir, it's visible now. You can continue.
Okay. So for that, I'll just show you what exactly we have to do. So for this, you have to collect training and testing data. This for mask, I have created a training and testing data depending upon the number of objects you have to do. Okay. So for this, we have two things. One is the person wearing mask, and another one is person not wearing a mask. So there are two things which you have to detect, and for that you have to create a specific directory. And talking about training and testing data is to train you, you have to see such type of objects, right? So training part, you should train yourself on more data set and you should test it on some smaller data set. So generally the ratio people use or we use is around 80 to 70%. That is your training data set. That means you have to train your machine on major data set and you have to test it on a smaller data set. So for that you have to capture images, and so that I have created uh,
Sir,
train and test folders.
can we
Yes.
zoom a little bit because in the stream it is not visible actually. The code.
Okay, code I'll zoom it.
Okay.
Okay, so for that I have created test and train. So in this, what we are going to do exactly is we have created a directory. After that, I'll show you the process of training the data set. Then I will explain the code. Okay. So first thing is
Sir, it's still not visible in the stream actually. We need to zoom
okay,
in.
okay. Just I hope it's visible now.
Can we do a little more? Yeah, yeah, it's visible. Yeah, perfect.
Yes.
Yeah, yeah.
So to build our own OpenCV model, what we have to do is like first thing is I'll just set up my internal camera as it is. Okay. So first one, it is asking there are two objects. Okay, for these two objects, we have to train it on our uh, like for these two objects, what we have to do is we have to train it on, like we have to collect data. First one is training data set and second one is testing data set. So as I told you, like we have to collect major part, like for training data set I will collect around 700 to 800 images, and for testing data set I will collect around 200 images. Okay. So I'll train first object as my face, which is not wearing a mask. Okay. So I have just started just so first thing we have to set up our directory. If not, it will create your directory. That's the code. We have created a function define make directory. If not, os.path exists directory. That means if your directory doesn't exist at that location, os.make dirs will create your directory. Okay, so you don't have to worry about it. So after executing that, we'll start running our code, and again I'll start training. So in that I'm training my face, which is without mask. This is the first step. I'll collect around 700 to 800 images. If you see the numbers, you can see like I can train the data set. Like these are my training images. Okay. So this is my face not wearing a mask. So I'll collect, enough, and I'll collect test images. So if you see the value has changed. Okay, I have collected. Now for second data collection, what I will do is wear a mask and I'll collect the data set once again. I'll show you the images, what exactly we have to do. So now I'm wearing a mask. Okay. And I'll start collecting the object. Same again for training data set, how much I have to collect? I'll collect around 700 to 800 images for training dataset. And see, you can see how fast it is collecting the images. And the blue color box which you are seeing is your region of interest. I'll show you the code how we can collect the images. So like we are almost done. 700 images, and I'll collect more 200 for testing dataset. No, it's not that maximum number. You can collect as much numbers as you want. The more data you're collecting, the more your model accuracy will be. Not accuracy, you have to train. Okay, that's it. And I think there is no third object, so I'm just skipping this part. Okay, so I'll show you where the data exactly is stored.
So we have some doubts here in between.
Yes.
One is what is training data set, and other is that does this mask detection work with handkerchief too?
Yes, you can it's almost while training you have to train it with the images along with your mask, and you can train some images with the handkerchief too. And also one more thing to reduce the processing, what I have done is see these are my images. We have reduced it to a 28 by 28 pixel. Okay, so it is very small. I'll just zoom it. So it's not able, I'm not able to zoom it to the max. And these are your test images, 0 1. Okay, so now in the one I'm wearing mask. So these are your images of, this is your data set where I'm wearing a mask. Okay, so now I think we have not trained, we have not using the third object. If you want to use third object, you can use if you want to detect with handkerchief, you can keep it as a handkerchief, whether the person is wearing a handkerchief or whether it is wearing a proper mask. Okay, so I'm deleting it from the test as well as deleting it from the trained data set. And the question you have asked is training and testing data set. It's you cannot use a complete data to train your machine. See, as a person, you need some knowledge to understand those things, and then you write a test, right, in the exam. So the similar way, what we do is we train it on some particular data, and then we test it out on some other data set. So in this case, I'll show you what is your train data set. Zero is your object where I have collected around 755 images. Okay, and in for the same zero means we are just labeling it as zero where I have not wear a mask. So in this I have 255 images where it is testing data set. Okay, so 700 images, almost like if you consider what's the ratio I have what's the ratio, is it 70-20 or like 70-30 or 80-20? 700 I think 735 or images I have collected, so that means 75-25 ratio it is, because training data set, whatever 0 and 1 object is having, I'm collecting around 80-20 ratio. So now after collecting the data set, okay, what's the step you have to do? I'll show you first what exactly we are going to do. I'll put the model for training and then I'll explain the code. Okay, so now after training this, I have collected the data. This is our first step, because without data you cannot do anything. Okay, after that, what if you're having a very less data? What if I'm having only 2-3 images of a single person? That is a very less data, right? So, and if you are having variations while doing it a live image classification, you won't be able to detect that image. For that, what we do is we augment the image means we scale it, we reflect it, we rotate it. So this is called image augmentation. So I'll show you in the PPT what image augmentation exactly looks like. I'll I'll explain all this stuff. So if you see this, the image of cat and image of a lion. So if you can see it properly, the data, it's the single image. Okay. But we have created multiple images using the same data. So this is called image augmentation, and Keras has, like, if you want to read more about it, you can you can go to your. See, Keras provides its free API, that is image data processing, and that's what we have used for image augmentation. And I'll explain what exactly it is. So till now, what we have done, we have collected our images. We have okay, we have only collected our images. So now what we are doing is we are augmenting the images. So this part, it is for collecting the image. I'll explain all the code. This part, it is for augmenting the images. It is in my mask and train folder. If you can see properly, it is having mask, and then my data sets are into train and test folder. So it will automatically apply this thing to my data set which I have already collected. After applying, it will also explain, like it will also tell you how many images. So it has found 1492 images for the both classes, that is your training data set, and it has found 554 images which belongs to both the classes, that is the one where I'm wearing the mask and the other where I'm not wearing the mask. Okay, after this, just try to understand the flow first. We have collected the data, we have collected the data, we have augmented the data, that means we have increased it. And like to increase the accuracy also, image augmentation is necessary. Okay, so we have found 1492 images, that is good amount of image to train a data set. This is very less because we are going to do it live. So after that, creating our model, what I'm doing is I'm applying artificial, I'm providing it to artificial neural networks for training our model. See, the way we are training ourselves, like by providing more and more data, by providing more and more knowledge, the same way we are training our machine to do the same. Okay, so I have started. I'll start the training. So for training our model, I'll also tell you how exactly artificial neural networks looks like. So I have started it. So this is how your neural networks looks like. Okay, if you see this, it will train it for multiple times.
Sir, just a doubt. Like, if I'm reducing the
Yes, yes.
if I'm reducing the pixels of a image, like, will it affect the detection rate, like accuracy rate, anything? Will it affect the accuracy rate or anything?
Not yes, like it won't affect accuracy, but it will affect your processing time.
Okay,
Okay,
okay.
so for this, okay, we have not entered this number of samples. I'll explain that also. So now we have got 1492 images in that for training dataset, that we have to enter it over here. Once I put it the model for training, I will explain the code what we exactly have done, so that we won't be wasting more time. So this is how your neural networks uh, processing, and it is an iterative process. It does it for the number of times you have kept it for training. So for now I have trained it, like I'm keeping it for 120 epochs. Epochs means like how much time you want to train your model for. And like it will count till 120, and what exactly epochs and all this stuff is, I'll explain right now. So after that, we are saving this model and we are using it for live image, like live detection. So now the model is like training. So by the time it reaches to 120, like what we'll do is we'll go through all the process what we have learned till now. So first thing is building your model, collecting the data set. I'll explain what it is. So if you have seen, there were almost several steps for that. Uh, let's get back to a PPT. What So now I have like the process, what it is exactly. Talking about this neurons, we have used artificial neural networks for training our model. Okay, that is exactly convolutional neural networks, which is basically used for images. Most of the time, it is used for images. So now we are using OpenCV for all these processes. I think we have, like I have told you, images already consist of pixels. Then type of like images, like colored channel images, and other one is your single channel images. The way we perceive images, that is your RGB. Okay, you see colored number. Okay, Prasad, let me know the comments. Like if there are any doubts, just do let me know.
Yes, just a quick doubt. Does epoch improve accuracy?
Yes, epochs, the number of time, the more you train the data, it always improves the accuracy. The more you learn, like it will always improve your accuracy.
Okay. Sir, can we just
Okay.
like click on the hide button that pop-up is at below?
Yeah, yeah, sure.
Yeah, thank you.
So now images are formed to reduce the image complexity. What we do is we convert it to black and white or grayscale images. But while converting in black and white, there are only two things. First one is black and white. Okay. But if you consider grayscale, you get a wide range between your complete black and your complete white. Okay. This is the reason we prefer converting it to your grayscale images instead of a complete black and white. So you get a lot of variations. So in this you can see variations of like a grayscale images. Like it can vary from like a like it can vary from complete black to complete white pixel. Okay, so what we use over here, convolution formula. So I hope everyone has like a grayscale is color. So like grayscale is just a color. Like instead of doing a processing, all this processing on a colored image, we process everything on a grayscale image. That's it. So
Harshita
these
is
are the shades.
Harshita
Yes.
is asking what is a grayscale?
Yeah, I told you grayscale is just a color. Like you convert your colored image to your grayscale image. So if you see these data sets, uh, well, so if you see this data set, like you can see this image is in grayscale, right? It's not complete black. It's not complete white. I hope it's clear to you.
Yes, yes. Yes, sir, it's clear.
Yes. Okay. So now black and white versus grayscale. Is that clear? Like why do we prefer grayscale? Converting it into grayscale, and the need to convert it into grayscale is like there are some classifiers which only works on black and white images, like cascade, Haar cascade classifier, and also the complexity to process these images is very less. Okay, so I hope everyone has gone through this formula. Those who are into engineering, into your like third year, not third year, into your first second year, you might have gone through mathematics, right? So in this you have met with this formula. What does convolution exactly means? What is convolution? I need answers from you guys. At least those who are like done engineering, or like those who have gone through a proper mathematics course, like they might know what exactly convolution is. So we use convolution for simplifying complex things as in signal processing. Mostly it is used in signal processing. So we use convolution to reduce this complexity of signals. We use it to reduce complexity of images. The same thing we are going to do it over here. So for example, everyone applies filters on your Instagram pictures, right? On your Instagram pictures or your Snapchat pictures. And what exactly it is? It's like playing with the pixel values. You apply some pixels over your image, and what exactly happens is you are not distorting the images. You are applying some attributes, or you are applying some thing to that image, but without disturbing that image. And that is all called like that is also a convolution which you are doing while applying the filters on your Instagram pictures. So now if I'm this is my main image. Okay, so I'm having Taj Mahal, and if I'm multiplying it with some other pixel values, so that means I'm convoluting it. So I hope edges are like Prasad, like edges are like visible to you.
Uh, yes, yes, edges are visible.
Yes, so we multiply it with some other like matrix, so that it's the image is not completely distorted, but we are enhancing or we are detecting something out from that image. Okay, so for this sharpen filter, like it's the same which you apply it in your PixArt or any photo editor app. What you do is you are just playing with the pixel values, and what you are doing is like if you convert it, like if you are applying this matrix of blur, complete blur. Okay, so what happens when you use a blur? What happens to pixel values to your when you apply a blur filter? Can anyone answer? What happens to your pixel values when you blur an image? So what we do is we multiply it with some other matrix or some other values to not distort it, but to enhance some characteristics from that image. So talking about blur, like it's about almost there. Drop the pixel value. What happens when you apply a blur function like blur is you average all the pixel values. What you do is you average all the pixel values, and if you get a slider in Pixar, if you are editing, if you are applying a blur feature, you get a slider over that, right? So that is the amount you are like all the amount you are averaging of your every single pixel. This is what blur feature is, and in the similar terms, you create different type of features as in filters. Okay, now getting back to our code, what I uh, told you is creating our image data set. Okay, then after creating image, what exactly happens in your neural networks? Okay, this after creating data image data augmentation, what image data augmentation means, we create multiple images from one single image. So now in this code, after creating your image data augmentation, what we are going to do is we are creating our model. Okay, model as in the one which is required to train your classifier.
Sir, can we zoom a little bit?
Yes, yes. I'm not explaining the code as of now. Once they get a clear idea about everything, I'll explain the code line by line. Don't worry about it. Okay, so like please let me know if you're having doubts. If anything is not clear with you, just do let me know in the comments. So now talking about artificial neural networks, these are the exact neural networks which are like which we have in our brain, the one which is one which process everything. Okay. So now for this neurons, what we have is first thing, take an example of artificial neural networks where I am having the problem statement. Just try to understand it. Just try to understand it. The problem statement, what we have is we are having so many images in front of us, and we want to predict image of dog or a cat. Okay. So on what basis you will detect an image, whether it is dog or cat? Try to understand the problem statement. You're having so many images in front of you, and what exactly you will use to detect the picture of dog and cat as a human. As a human, you're having so many images of animals. How you will identify whether it is dog or cat? Please answer by the time I like explain your doubts. What is har cascade? Har cascade is classifier based which is based on black and white images. Like you have to train it on the basis of black and white images by its features. Okay, cool. Size, attributes, characters, features. Okay, so everyone has got it. Like you can detect on the basis of features. Okay, but as a machine, it's not directly like you show a picture of cat, it will identify it. Attributes of animals, that's it, exactly. So each input, try to understand neural network like this. Each input is having some weight which is in range of 0 to 1. Each input is having its weight which is in range of 0 to 1. Okay, so now in this, first image is of dog, second image is of cat. So when I'm passing it to neural network, there are some filters which filters out this characteristics, and then at the end you get an output value. So for this example, for example x1, I have passed an image that is your picture of dog. For x2, you have passed an image that is picture of cat. And just try to understand, everything is passed into your neural network, it goes to your output value. It's check whether it's compare it with your actual value. Okay, there is difference between actual value and your output value. So now this difference is back propagated in your neural network, and these weights are adjusted. Okay, these weights are adjusted, and the more on the basis of this weights, your neural network actually classifies whether which object you have passed into. Okay, so now how this neural networks exactly learn? So it is a complex process. I'll just suggest you to please focus into this. What exactly is? By the time, if you have understood what we have done, we are passing x1 as picture of dog, x2 as a picture of cat, and every input has its individual weight. So for now, just try to understand. We have to classify a dog. That's it. We have to classify a dog from several images. So this is the way. There is input image, we do convolution to it, we do pooling, we do flattening, and then we pass it to your neural networks for your predictions. Okay, I'll get back to you what is activation function, every single thing. Just it is in further slides. So now for an example, we have input image of dog. We apply convolution to it. That means what? We are just simplifying it. Okay. After convolution, we are pooling, max pooling, and flattening are two steps, which like you cannot pass a complete image to your neural networks. Just try to understand that why we do all this process. There are so many questions related to this, like why we cannot directly pass it to your neural network. You cannot pass directly your input image to your neural networks, and for that we have to convolute it. You have to simplify it. You have to convert that whole image into a single array. Okay, and then only you can pass it to your neural networks for the further prediction. So the same way we have done. I'll explain what exactly convolution means. Convolution means, see, for example, input image, you're having picture of dog, it is having some pixel values. And then there is a feature detector. Feature detector means the filter which you apply on Instagram. It's the same, any feature detector. So the first 3 by 3 matrix of input image gets multiplied with second 3 by 3 matrix. In the similar way, you multiply your matrix with other 3 by 3 matrix. Okay, so now this matrix is get filled by multiplying 3 by 3 matrix to other 3 by 3 matrix of your feature detector. Okay, so in this way, for max pooling also, you simplified the image. Then at the end, flattening, you create a one single layer, and this single layer is passed into your neural network. Okay, so now in this neural network, what you are doing, you are predicting on the basis of features. So before passing it to your neural network, what you are doing is you are just simplifying it. Just try to understand this. There are so many content available. You can just go out and search about all these things. Okay. Then after passing it to your neural network, what we have is, for example, this is picture of dog. So now what activation function is, someone has asked me what activation function is. Activation function is something which filters out what are the exact characteristics for that. There are so many activation functions like rectifier function, sigmoid function, and each is having their different characteristics. So now, for example, if we consider a picture of dog, okay. So in that, what you have is long nose, fluffy ears, and curved tail. Okay. So the one which is having higher weights is your features of dog, right? I told you the weights are always in range of 0 to 1. So the one which is which is near to your value 1, that is your matching features of the input image. Now if we take picture of cat, the other three things which have fired up, which are close to 1, is small nose, pointy ears, and straight long tail. Okay, this might be the features of cat, and on the basis of this you are just predicting whether it is dog or cat, and this process is like you have to back propagate it every single time. So now what you have to do is, let's check how much like our model is trained. So if we just scroll down, so if we check, our accuracy started from 0.77, that is 77%, to, like if we check, it has reached around 99%. That is too much, I think. Like, so let's see how much our model has been trained, so we can save it as like mask.h5, that is HDFI file format in which you can save your data set. Okay, so I'll just save it as mask.h5. After saving it, I'm again loading it, and let's see how we, like if it is uh, we are just again testing your mask.h5. And what were the two things instead of sitting idle, what we are having? What was the first image I have trained on? It was without mask, right? And what was the second thing we are having here? With mask. So these are the two labels. Zero, the folder name zero is having without mask images, and the folder which is having one which is with mask. Okay. So now I'm just labeling it. We are creating one function to get this labels, and after that we are just testing it onto your camera. I'll just turn this off. So I'll do a live. Okay. So we have not imported it. So we'll just test it on your real-time camera, what exactly it is showing. So once the model is trained, you can save it in H5 file format, that is HDFI. There are many data like data storage formats in which you can store your model. So I'm importing the same model which we have trained earlier. Okay, so now I have assigned the labels, one which is without mask, which is in zero folder, and then we are just doing a live. So now if I'm in front of my camera, so it is showing me without mask. Okay. Now if I'm wearing a mask, let's see if it has trained properly or not. So now if I'm wearing a mask, it is showing with mask. Okay. So if I'm removing it, it is showing without mask. So that was all for like how to train your model, and like I have done it live for the first time. I have trained the same thing, like the one which was detecting enjoying, whether the person is enjoying the session or whether the person is sitting idle. And on this thing you can also add the user interactivity. Okay, so now I have trained a complete model, and the same thing you can also build. I'm closing this window. Now we'll get back to our code. I hope this session is like running too long. I'll explain you shortly what are the things. Like, see, you can do it. I'll share the code files. You can do it on your own. First thing is like to get a direction. What are the things you have to do it? So this code is like to create a directory where you're actually working on. If not, it will already create a directory. See, if I have mentioned here mask slash train slash zero, that is my folder location. Okay. So now we are going to use OpenCV to build our data set. So import CV2 is your main library. So capture, in that video capture, you're using zero. That is your default internal camera. If you keep it one, you're using external camera. Okay, I'll explain the code. Don't worry. So now we have almost 9 steps. Okay, so first step was like we are having 9 if loops. So this is the reason we are taking while I is less than 9. Okay, now after your video capture is started, like this is for collecting data set. Okay, now in this what you have is you have a frame, you create a frame. This is your region of interest. I am sure will display what you are having exactly in front of you. So now in this code, I'll explain what it is. If I is equal to 0, that means your first step. This is for collecting data set. If you have noticed, you were counting the data set, right? Like number of images you are collecting. So initially you set it to image count is equal to 0, and cv2 dot put text. Put text is the function where you put text on an image. Okay, which allows you cv2, that is computer vision library, which allows you to put text onto your image. Now on which image you are using? On the one which you are already created, that is your main frame. Now what you have to put text, please enter to record first object. Okay, this 100.100 is the size which you want to display it over there. cv2.font hershey is your font which you want over your image. There are multiple many types of font. This is your width, and this is your color of the image, and it is always in BGR. In Python, like in OpenCV, it's not in RGB. First one is 0 and it is 8-bit color. So its value ranges from 0 to 255. So first one is B, second one is G, and third one is R. So if you have noticed properly, the color which you have got was your green color. The text was written in green color, right? So now again if we are taking second thing, you are recording the second training data set. You start recording the training data set, that is the cv2.putText function, and the data set is saved in this file location. Okay, now image, right? Like what you are storing, cv2.image, right? I am right allows you to write that file, and what you're having, you're storing it into .jpeg format. Okay, now same process for your test data set. If you noticed earlier, this was for your training data set, and this the same procedure for your test data set. Okay, now the third thing was after training and testing, if you have noticed, we used to stop the process. Okay, third thing, press enter to record the second object. After you press enter, you start recording your second object, and then after collecting 700 800 images, you started collecting the test data set, that is 200 300 images. Again, for that third object, it's the same procedure. After finishing it, you just have to close this code. Now, Keras documentation, that is, you can see it on the website of Keras. It is like you can use it for image augmentation. We have number of classes. How many number of classes? Two, which was the one which was using mask, another was not without the mask. Okay. Now, image rows and image columns. If you have noticed, there were very small images, that was 28 by 28 pixels. So you define it over here. Now batch size, what does exactly batch size means? Like how many samples you want to provide while training. Okay. And for that, this is your image augmentation code, like whether you want to rescale it, whether you want to rotate the image, then what should be the range. It's like you can play around with these numbers, okay, if you want to try. Then for train generator, like what type of image it is, like class mode, whether it is binary or you're having very many categories. Now creating a model, what you can do is you can pass a complete image directly for a CNN I'm not talking about you cannot pass a complete image, right? You just pass it in the range of array.
Sir,
That's what we done. Yes, yes.
can you repeat the last part because your audio was glitched?
Which part?
The creating your model from the start.
Okay, creating our model.
Yeah.
Okay. So creating our model means like I told you, like you cannot pass an image directly for a CNN processing, convolutional neural networks. So what you do is you convert that image into one single array and then you pass it for neural networks processing for your further prediction. So now model equal to sequential, which converts all your image into a single array. And this is your layers, max pooling. This is your first layer. This is your second layer. Okay, and activation functions you apply it over here, whether it is rectifier function, whether it is sigmoid, or it's any other function. So I'm just giving you direction. What are the things to look after? You can search about activation functions, which to apply and why that function is used. Because see, for first three layers we have used rectifier, that is relu. Its name is relu while writing, like while coding. Then if you see this, this is flatten. Flatten means I told you you have to pass a full flat layer. Okay. Then after that you have to pass it into a final layer, and then you have to predict the output. Predict the output means you have to train your model for that. So after creating your layers, what you have to do is you have to train our model. And for that, there are some metrics where you identify how much accuracy it is having, how much loss you're having. So for that loss, you're using binary cross entropy. There are many things. I'll show you in presentation what exactly these things mean. So if you see this, what thing we are talking about? Loss function. Okay. So there are many things in which you can carry out the performance. You can detect the performance of your model which you are training. So mean square error, MSE is one of them. Then binary cross entropy. If you're having binary images, if you're having many images with many labels, you can use categorical cross entropy. Okay. So after that, optimizer. Which optimizer you want to use? What is optimizer? I told you about weights, right? The weights you have seen was processing. So optimizer is used like how far like you have reached. Like there are many. I think it's see SGD, stochastic gradient descent, is one of the optimizer. RMS prop, ADAM is also an optimizer, which which are based on adaptive learning. And then metrics can you can use, like accuracy is one of the metric to judge your model. Then you can have there are many more metrics like accuracy, precision, recall, F1 score. I'm not talking about everything. You can just google it out and just check whether what type of metrics you can use. Then number of training samples, that is number of images I have used. Number of validation samples, that is your testing samples on which you are testing the data. And number of epochs means how many times I have iterated that neural network. Okay, how many times I have done that backpropagation thing which I have explained earlier. So after all this, you have put your model for training. So and after that, after training your model, you're saving it in H5 format, that is your HDFI file format. And again, you're using from tensorflow.keras.models import load model, which is your use loading the main model which you have already created. Okay, so after that, we are just creating labels for zero, the folder zero where all the images were stored were without mask, and for one where all the images were stored were with mask. Okay, so after creating labels, what we are having, we like after creating labels, we just want to test it on our real-time data. So again, I'm doing it. I'm loading it. I'm loading the data mask.h5, and again I'm doing it live. Okay, so again, if I'm in that region of interest, it is showing me without mask. I think the uh, text is out of the, and also if you want to see region of interest, this thing is only showing the object which is in the region of interest. So for example, my face. Okay, and again, if i'm if I'm displaying this part, like you're having your main frame, you're having your region of interest, and you're having also grayscale image in this corner. So if I'm putting the mask, it will show me the exact same thing, like it will change it to with mask. So that was all for your uh, object detection model. Like if you have like I'll share the code file, and what I expect is like you can train your own model, you can detect your own objects, like any object if you want to detect, you can detect using this OpenCV, and like the one which we have used is convolutional neural network model. So how to build an app? Okay, the model which you are using, I told you how to train your model. Okay, if you want to deploy it in your app, you can use TensorFlow Lite model, like which is specifically used for your uh, TensorFlow Lite model, which can be deployed in your Android apps, or else you can use Core ML. Core ML is for like you can use it for iOS thing. Okay, so building an app, like once this thing is like once you can create all this, you can deploy it in your mobile phone. So now your task is to create many objects. Like I told you about to increase the user interactivity using this thing. Like what you can do is you can create many more class labels, which like you can detect whether the person is idle, sitting idle, whether the person is enjoying the course, or whether the person like is laughing. So that means like it is having it is actually interacting with the course. That's it. And for mask, you can just create in the similar way, the way I have done right now. I've shown you the live mask detection. So is there anything else?
Sir, we have a doubt from Sanket. Can you
Yes.
suggest how we can use ML and data science in farming and weather forecasting while using image processing?
Farming and weather forecasting. Okay, let me tell you one single application of this, which like if you see image processing in farming.
Okay.
So to measure the crop quality health, so image processing, you can collect data, the plants which are actually healthy. So if you go to north side, so this farms are in range of kilometers. It's not like just 1 or 2 kilometer in range of. So these farms are in range of like in many kilometers. So at that like looking at a very large scale area, we cannot like once it is getting infected, we cannot afford the pesticides. Like this plants are just getting wasted. So what we can do is like we can collect images with the help of drone, and we can also collect healthy plant images. Okay, healthy plant images, the one which are grown in the laboratories, and we can just compare it with the same plant which is actually in the range of those which are actually in the range of very large scale area. And by comparing these two images, you can actually find out which plant is healthy, which plant is not, and then you can also detect the area where it is actually started infecting. So in this way, you can like help this image processing in farming. Anything else?
Sir, another question was that can we use the same code to deploy in Raspberry Pi, or do we have to convert it to something else, like whatever?
Yes, it's a Python code. You can use it in Raspberry Pi. Just that if you're using a TensorFlow model, I think it will be very heavy for Raspberry Pi. So better you can use TensorFlow Lite model.
Okay, Sanket, I hope that answers your both questions. So another just a quick doubt, like we separated the data into training and test using like gesture one and that. Can we do that using the train test split library, which sklearn provides us?
Train test split is basically if you're having, yeah, you can even use that. But if you're having a text Excel sheet, okay,
Okay,
so in that what it does is it splits the file into your, like if you're having thousand values
okay,
in your Excel sheet, what it does is train test splits it into the ratio. Okay, so here we have actually coded manually. We are taking manual data for that. Like we have collected manually 800 images, 800 for training set and 300 images for testing set.
hmm,
That's the same thing we have done it over here.
okay.
Any
So,
other doubts?
no, sir. If anybody has doubts, just put up in the chat so we can answer them. Guys, just put up
So
your
if you're
questions.
having any so if you're having any doubt for all the concepts explained in this tutorial, or else any code thing which you haven't understood, just comment it in your like comment section.
Sangeeta is asking why
Uh,
not. Yeah, sir, take the.
yes, yes.
Why not using color directly? Why need of conversion into grayscale?
Okay, so first thing is I told you about grayscale images is you reduce the processing, right? I've shown you there was a specific object which was in a grayscale. Even the data which we have collected was in the grayscale, right?
Yeah.
So grayscale, converting into grayscale is first thing you reduce the complexity. Okay. So for CNN based models, so grayscaling means like you are not exactly having those all three channels. You can use, like there are some models like if you want to learn more about this computer vision, you can use other models which can directly work on your colored. Like you can use colored images too. So for example, if you want to train it on SSD models, okay, that is single shot multi-box detection, SSD. So if you are using SSD models, you can use colored images directly to train your model. Then SSD, there are another models like YOLO models. You can use those type of things. And what we have done is we have used CNN for this detection.
Okay. So, sir, how can we like create an app? Like, is it for only an Android app, or can we use this in a web app also? And
No,
like,
no, no. First thing I have explained is to create a desktop app. This one, the one which you have already created. Once the model is ready, it's very easy to deploy it. Okay. The second thing for Android app, I have told you, you can use TensorFlow Lite model. Okay. And also I have created an Android app, but like the Android Studio I'm not having it right now. I'll upload the screenshot for detecting the user interactivity. And the third thing is for
काय
iOS, you can
सांगितलं
use
रंग काय
Core
सांगितलं?
ML.
Yeah, sir, it's clear.
So one more doubt is there whether the image is in black and white. You told that we are cascade whether the model will provide. Like I'm not clear with your question, but still, har cascade is the classifier which requires your black and white images for training. You cannot train it on a colored image. Like it requires black and white image for training. Anything else?
Guys, just put up your questions in the chat. I guess no more. Can you explain processing a conversation sound using AI ML? What resources do we need on software side?
Can you explain processing conversation? Sound. Okay. For sound, there are many more libraries. Like you can use Pi Audio, then you can use GTTS, that is Google Text to Speech Translate, like Google Text to Speech, GTTS. Okay, so you can just Google it out. You will get more text, like or else if you know something about like Google, uh, like they directly provide you a platform to do all this. And especially if you want to deploy it into an app, you can use Firebase too, which already provides this ready-made models. You don't have to do this training, testing, all this stuff.
Sangita Paul is asking from where do we get the code. Sangita will put up this code on the community, so you will get this on the community.
So like the last thing, if you want to like actually build something in this, like instead of sitting idle, what you guys can do is you can build something based on this classifier, and you can just upload it into your profile. You can add this project into your profile too. So this was all about image processing. And what are the, and if you're having still any doubts, you can just connect with our Let's Upgrade community. Then even if you have, like you can, like if you have any projects, like you can directly upload it onto your LinkedIn. You can tag us, like you can tag like Let's Upgrade, you can tag me personally, you can tag Prasad, so that like we will get to know like you have done something. Like because see, if you are like if it's really helpful for you, like if it is adding some value to you, you can just add this project into your profile, you can just put it into your LinkedIn. That and also do let us know by tagging us like into your LinkedIn profile, like into your LinkedIn project which you will create. And it's not like just for your face mask or like using uh, detecting interactivity, like you can detect any other objects.
Another doubt you are getting is, can we process another analog values like pressure, temperature on these softwares?
On what type of software? These are like pressure, temperature values will be text data, right?
Yeah.
So you can use basic libraries for processing that.
Okay.
If it is a text data, you can use basic libraries. You don't need anything else. If it is something predicting, you can use these models, artificial neural networks. Then are many more
अरे
models for
आवाज
text
नको करू
processing.
आई. येता आवाज आहे बोललेला आहे का?
I hope it's clear to everyone, right, Prasad?
Yeah, yeah. One question was, if we are beginners, so how are able to coding such this program? I guess they should start with the basic pre-processing data and stuff, and then uh, go ahead. So what will you suggest to the beginners who are trying to like do AI/ML thing?
Okay, so like first thing I would suggest is like uh, you should learn on basis of projects. Like take one project and see what are the, like I told you now, like detecting a face mask. So what are the things I have mentioned in this whole tutorial? You should learn about each and everything. You should study about each and everything. You can build this app, and while building this you will get to know about all the things which I have used in this project. So this is how you should proceed. You can also start with basic projects like detecting a phase, then color conversion, converting black like colored image to grayscale image. Like these are the very basic steps. So from that you can start learning.
Okay. Which library is used most in artificial intelligence?
Which library? Like
Like,
it depends upon your requirement. What do you exactly want to do? If you want to do sound processing, there are other libraries. If you want to do image processing, you can use OpenCV. Then you can use this for like you can use TensorFlow where you can do all this stuff.
okay, I guess that's all
So
doubts we have cleared. No more doubts we are getting. So we are done with the presentation, right?
yes,
Uh, so guys, that's all for today. We'll be coming up with new meetups every Sunday. Like all the details will be given in the community and our Telegram channels. So please be active on community and our Telegram channels for all the updates. So yeah, thank you sir for such a wonderful session, and we'll
yeah,
be ending the session
thank
soon.
you.
Thank you everyone.
Yeah.
I get up, time is barely on our side. I don't wanna waste what's left. The storms we chase are leading us, and love is all we'll ever trust. Yeah, no, I don't wanna waste what's left. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways, and on we'll go. Through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways, and on we'll go. See the horizon, turn us to thousands.